ZVS driver, flyback transformer, capacitor 60 nanofarads, spark gap, 2500 turn secondary coil, top load, primary coil near the center of the coil, 19 volt input, and output. The main downside is that you'll notice this has a very small secondary coil on the flyback transformer, and so it only outputs 1 to 2000 volts, and so that's the maximum that you can get out of the spark gap. So let me discharge it. Don't have to. And adjust it to be further apart. And now, you'll notice there's a much higher output. You get the point, right? So that's my Tesla coil. As for other things, my radio frequency ground consists of just this aluminum plate on the concrete. It goes underneath as well, but just this size should be plenty for this size Tesla coil. If you're making a really big one, then you would probably already know this, but you would want to stick a copper pipe into the ground instead. That's a pretty foolproof RF ground. Another thing is that this only has a low output voltage because of the turn ratio, so it has a lot of high current, especially since it's coming from a ZVS driver. So I'm putting it through a resistor, otherwise you would see a lot more sparks here. And the resistor's there because this diode can only handle 5 milliamps of current. And I don't want it to explode like this one did. As for other things, this has a somewhat high coupling because it's right to the center of the secondary coil and it's close to it, but it's obviously on a piece of ABS pipe, so it has a lot of insulation to protect against sparks. That's pretty much the entire thing except for the capacitor. You'll notice that the capacitor is being weighted down because it has to be compressed. It's basically just a bunch of layers of aluminum foil, then a transparency film sheet, then another layer of aluminum, and just a bunch of those capacitors hooked up in parallel to equal anywhere from 40 to 60 nanofarads. Quite a lot, and just at 1 kilovolt, it's enough to send a jolt through your whole body, so I don't recommend touching it. It's obviously, you need a book too, or if you have the supplies, cut up some wood and use some screws. It makes it look a lot better, but I don't feel like doing that. And it's also not totally tuned to resonant frequency yet. Right now it's at around 10 terms. I'll keep tuning it until I get the biggest sparks, and eventually I'll get more wire to make another one of these cardboard wire discs. This has no insulation between the windings, by the way, so it's pretty much indestructible at the cost of a lower output voltage. And that's the whole thing. Bye. Okay, one last thing, just to show how low power this thing is currently. This thing barely lights up at all. And you can see it flickering, but that's about it. So those pulses aren't, well those are, but the ones coming out the top load, they're not even harmful. The only reason why I'm not touching them is because I'm paranoid I'll somehow die of a cardiac arrest anyway. Bye.